right, so now we're going to do lecture number 4. In the last lecture, we talked about the atom, the history of the atom. We went over electron configurations. And so the next thing you need to know for the SAT2 is the periodic table trends. And so this is pretty important. Now, first you should know that Dmitri Mendeleev and Robert Moseley get the credit. Really, Dmitri Mendeleev gets the credit. He organized everything by atomic mass, okay, and Robert Moseley did it by atomic number, but it's still okay. Your periodic table, okay, brought to you by these two men. Make sure you know it. Okay, secondly, metals versus non-metals. Okay, so the big difference between them, they're ductile. Okay, so let's talk about the metals. So metals appear on the left side of the periodic table. All of these guys are metals up until boron, silicon. When you come over here to germanium, astatine, or this is arsenic, right? And you get to these metalloids, then we have the non-metals. Very few non-metals over here, but everything on the left side are metals. And so metals, since like 2/3 of the periodic table is metals, we should talk about them. Okay, so they're malleable. Malleable means that they can be hammered out into like nice thin sheets. Ductile, right? Metals are ductile because you can roll them into thin wire. All right. In addition, they're shiny, they have luster, right? And they're mostly solid except for mercury. Mercury is the only one that's liquid. All right. In addition, they tend to lose electrons. So that makes them cations. They're positively charged. Okay, and that looks pretty good. Now, as for our non-metals, they're soft and brittle. A lot of them are gases, okay? Some of them are solids. They have no luster. They're poor conductors of electricity and heat, while metals are great heat conductors and great electrical conductors. Okay, and then usually they tend to gain electrons and form. Now, notice it says cations here. That's a small typo. Let's just cross that out. And let's put anions, okay? We don't want to say cations. We want to say anions. And these are minus charge. Okay, while the positive are over here. Those are the plus charge. Small mistake, no problem, okay? Let's get this out of here. Okay, next are metalloids. Okay, these are like half metal, half non-metal, right? They're sort of like in between. Some of them conduct electricity. They have the properties of both metal and non-metal. So here they are, and you need to know them. Okay, boron, silicon, germanium, arsenic, okay, antimony, tellurium, and astatine. All right, and they're really here for you. And so if you could kind of get a mental picture of what this looks like, this little staircase, you could just draw the staircase on your periodic table when you get it on the SAT2. It's not going to be there for you, okay? So just in case they ask, know where your metalloids are or your semi-metals. Okay, so electronegativity. Now, there's only 4 trends that we should know on the periodic table. Electronegativity, right? Ionization energy, atomic radii, and ionic radii. So electronegativity, we discussed, it's really your affinity for electrons, okay? How much attraction as an atom do you have for electrons? The most electronegative, everybody knows, is fluorine, okay? Fluorine is exactly 4.0. Okay, oxygen is like the second one. I think that's 3.5. Chlorine's like a 3.2. And you can look it up in your reference tables and see. But the ones on the left side have very low electronegativity, especially as you go down on the periodic table. And then it starts to increase as you go exactly in this direction. So in other words, electronegativity increases as you go from left to right, but it also increases as you go up in the periodic table. Okay, so this is really important. How badly you want that extra electron. It actually makes sense that fluorine is, because it has 7 valence electrons and just wants 1 more, okay, to become a noble gas or to fulfill the octet rule. Okay, the second one I had mentioned was the ionization energy. And so this is the amount of energy needed to remove an electron from an atom. So the metals don't mind, okay, if you grab an electron from them. They have very low ionization energy. Hey, sodium, can I take an electron from you? Sure, I want to lose 1. I want to fulfill the octet rule. I have 1 measly valence electron. If you remove it, my next shell will have all 8. Oh, really? Okay, so then in other words, more energy goes from left to right. Okay, over here, try to take an electron from neon or one of the noble gases. You'll need an enormous amount of energy. In fact, for the closer the electron is to the nucleus, the more energy you'll need. So therefore, helium has a very high ionization energy as well. It's much different from krypton because that electron, the noble gases have fulfilled outer shells. However, it's so far from the nucleus, you can use less energy to steal one of krypton's electrons, but there's no having, this would be the highest, right? Helium. Okay, and notice something. ooh, it's in the same general direction as electronegativity, right? It's pointing in the same way, so you can literally go up to helium like that. Keep that in mind. Okay, next, atomic radii. So this is the distance, as we said in a previous lecture, from the nucleus of the atom to the farthest electron. And it's measured in picometers, okay? So that would be PM. Very, very small units we're measuring. Now this is interesting because the radius of an atom actually goes the other way. You would think, wait, why would neon have a smaller radius than lithium? It does, okay? It does because there's more protons here. And remember, this is all in the second shell, right? This is in energy level number 2. So, you know, there's 10 protons here, pulling those 10 electrons or those 8 electrons closer. All right, lithium, on the other hand, has 2 electrons plus an extra one. And that extra one has to only battle 3 little protons. And so it gets to go farther away. All right, I hope that makes sense. But of course, the atomic radius definitely would increase as you go down the periodic table because elements are naturally getting bigger and they have more electrons. And so that just makes sense. But just keep in mind, it does not go this way. It goes the other way. And so please memorize that, okay? Very nice. Try to envision it like I said. It's a tug-of-war battle between protons and electrons. And then the final thing that we have to know is the ionic radius. This could get a little tricky, so be careful. That's an ion. That means the atom is charged. And so what I want to show you here is that the metals, since they lose an electron, they're going to have smaller ionic radius, okay? And so it's a little tricky, but the metals, it's going to decrease as you go this way, okay? On the other hand, on this side, it increases. So it increases as we go this way, right, the ionic radius. And then it should also increase as we go down, okay? So across and down. See, like the chlorine atom has a very, it's not, that's calcium. Chlorine is over here. Okay, and so out here, this would be just the neutral chlorine atom. Look how much bigger it is. Okay, now look at the neutral sodium atom. Neutral would be this gray color. And then the cation is even smaller. Okay, and so that's it with the periodic table. Those 4 trends, if you know them, you'll be very, well, they'll say, maybe they'll give you a list of elements and say which of the following has the highest electronegativity, or which of the following has the highest atomic radius. Okay, so with that said, guys, keep on studying, and I'll see you next time. Be safe.